Okay, let's begin with number 5 today. Okay, this A-level paper. All right, this past year. Okay, then 709. And here we have a diagram which shows a solid cylinder standing on a horizontal circular base with center O. And then and radius 4 units. Then the BA has a diameter. Okay, what does all this mean? Let's see part by part. This is center O. The radius is 4 units. Of course, it's signified up there. The same as telling each of these lines are all 4 units. And then BA is a diameter, meaning that AB or BA is this whole thing. That means this could be, or rather it is 8. 4 times 2, double the radius. Okay, and then what else they say? And OC is 90 degrees to OA. So OC and OA is 90 degrees. That's to signify the XYZ directions. Okay. And the 3 axes, 3 dimensions. Points O prime. So O prime, A prime are all here. O prime, this is A prime, this is B prime, and C prime, all line. Okay, on it. This part, these 4 points at the top there. On the upper surface of cylinder size that O prime all vertical, and the length is 12 units. So it's just saying that it is placed on the same plane. We say in the same plane. Up here, the plane is just being the upper part of the cylinder surface, surface area there. Okay, on that. The midpoint of BB prime is M, so BB prime is the middle down here, it's the midpoint there. Okay, the unit vectors in IJK are parallel to OA, OC, and OO prime respectively. So OA, we have here, OC and OO prime. The unit vectors signify the 3 dimensions. Okay, so we have the 3 dimensions signified by that. All right, and then the unit vectors, okay, they say today. So express each of the vectors MO, MC prime, please take note, MC prime, in terms of I, J, and K. Okay, you want to express each of it in terms of I, J, K, and hence find the angle OMC prime. Okay, we're going to find the angle OMC prime. Okay, let's try that please. So the first part is the MO. Okay, let's try to do the MO and MO and MC prime, right? So I'm just going to do it here so that it's a bit easier to see in this diagram here. Let's just widen this part of the screen so we can, write on it. Okay, okay, bring it that. Okay, let's try to mark the MO part. So M is here, O is there. So I'm just going to draw a line joining the two. This is what is called as vector MO. So what we do is we put an arrow like that. The vector MO is like this. All right. So MO, okay, so we start here, the first part. So MO will be, so we must think in a few dimensions because there are 3 dimensions here. So to find the vector MO, and the IJK is sensitive to the definition given. It means I'm going to signify each of it carefully. So MO is like going along here first. If you notice, this direction relates to K. And the length it talks about relates to the number 12 here, half of that, midpoint. So the midpoint part tells me there's half of 12 or 6. And the downward green arrow would signify against the direction of K. K is positive pointing up. So it becomes minus 6K. So this component, we add that symbol to signify that it's a vector. So minus 6K, this part. So, and then it's like walking. So the red line, you want to walk from M to O. I walk from M to B first. And after I walk from M to B, I walk from B to O. So we're adding like that. So the resultant vector, usually we signify a double arrow like that, MO, to show this fact. So now how about this line, the BO line? So if we look at it, the BO line is in the direction of the I. Oh, it's the direction of the I. And the radius, though, its length, it's actually the radius of the top here. It's the number 4. So it's in the positive direction, same arrow, same like the I. The direction is same, so it's positive. So this we can call it as 4I. Okay, so I'm going to write all this here. So in terms of vector, that's the details. So people just normally write it as MB plus BO. So we have MB plus BO like that. And then the next line, the MB, we just found, or we just saw that it is the green one, negative 6k, and then the brown one, the BO, turned out to be 4i. So in other words, this is just this just tells me the MO is just 4i minus 6k. So this is how we find in terms of ijk. So the j component is 0, so we don't need to write that. And we can see why, because it's no towards the j side, right? It's on this plane only. We call it the ik plane, if you want to say it. And then let's try the second part, please. So now we need to do the MC prime. So MC prime looks like this. Put an arrow like that. So let's have a closer look. Where's the M and where's the C prime? Aha, the C prime is up there. So what I'm going to do is I'm going to clear this so that it's a bit more easy to see. Okay, we need to pull the diagram a little bit down. Okay, let's move that a bit. MC prime. Aha. So this would suffice for that. So we wish to find MC prime. So let's join another line. Let's embed also. So from M, we join to the point C prime. So how do we determine a vector like this from this picture? All right. As before, we need to move it a little bit here and there. So the trick is, let's say we want to go along this line. See, the trick is to use the earlier one, the MO. If we don't use the MO, we have to think too much. So let's use the MO part. That means I do the complete triangle first. Always like triangle or polygon addition is used to find vectors. So the overall is MC prime. So this is the double arrow for that being the resultant. And then I want to walk from M to C prime. Just think of like walking. So it's the same as if I walk along M to O. Why do we link to O? Why not walk to other points? Because O is the point of origin, the definition. That's where the measure begins. So I walk to M to O, and then because all the calculations are from O with respect to O, in other words. So then O to C prime. So it kind of makes sense heuristically first. And then now the details. So this is equals to. So this will be MO, walking from M to O, and then plus O to C prime. Okay, O to C prime. Then we pull it off like that. Oh, so we add like this, and then we use the earlier result. Okay, I'm just going to put an arrow to signify that. Ta-da, an arrow to tell that is the earlier result. So it becomes, I'm going to write in light green to keep it in the same color. So 4i minus 6k. Let's take note. This is 4i minus 6k. Now, how about OC prime? Okay, looking at this OC prime, then we realize this two can be added with another two vectors in that along that line the other side, meaning that from here to here, okay, let's say we signify the color blue. Aha, you can see that. Just added a blue color there, and then let's say we add the orange color vertically upward like that. Ta-da! Oh, it's like walking, but in that direction. So the brown vector now behaves like its own. What we say resultant by itself. It's like a mini resultant itself now. So it's the addition of OC. OC, yeah. So I'm just going to write the blue one, OC first. And then it plus with the orange one. That is walking from O to C and C to C prime. Okay, just horizontal and vertical lines with respect to the planes given. But it's the IJK direction. That's why we choose that. And then from which we can further deduce. Okay, let's rewrite this first. So this is 4i minus 6k, and then plus, what is this? OC is, So in the direction of the j, so we need to take a value. It's a radius. So magnitude doesn't depend on direction. So the OC will still have a magnitude of 4, but it's in the direction of, as you can see the letter there, exactly overlapping on the j. Okay, so that's how we know it's plus 4j, yeah? And then the C prime part, vertically upward, so how do we calculate or compute that? So you can see that in terms of magnitude, the distance, that means like this entire height for the orange line is 12 units. So vector is a magnitude, so 12, then the direction is going upward, so it's positive towards the k. Can you see the parallel line, k upward is positive. That's why here is plus 12k. So this is how we write the components of a vector. Now what we need to do is just treat it like an algebra. as though it's in algebra because it obeys the law of algebra with respect to like just two other terms with k. So we just need to regroup and compute. So 4i, normally we take in the direction of ijk. Then I copy the 4j, a sign of a number is on the left. That means j is the c left plus 4, that's how I know. And then here, let's say we write the 6k minus 6k first. And then the 12 on the left is plus 12k. All right. And then we can simplify this to get the final answer for this part, which is 4i plus 4j, and then 12 minus 6. This two is like algebra part. That's what I meant. And this is 6k. There we have it. So this is the vector MO, and that's the vector MC prime. Yep, that's it on this part. And then let's scroll down a little bit to do the second part of the question. Then they say, hence find the angle OMC prime. Okay, how do we do this angle OMC prime? Okay, let's go a little bit in detail now. So for the second part, to find the angle, let's put it this, find angle OMC prime. Oops, sorry, OMC prime. Okay, so angle OMC prime is signified how? So O, M, and C prime like that. Okay, so where is that angle? Let's try to color it first. Aha, it's here. So we need to use a fact of vector now, a fact of the multiplication, dot product of the vector. So dot product tells me that. So we use the dot product formula. So dot product formula of a vector for 3 dimensions looks something like this. So you know why we use that? Because we always relate to the earlier part. That will be a clue without them telling. So the MO and the MC prime. So you can see that these two are the sides of the triangle here around it. MO is downward, MC prime is like that. So I'm just putting a slight color to show that the angle in between. So the dot product of these two, by definition, let's say even if you call it like this is vector A and this is vector B, just simply putting it like that. So the dot product definition looks like this. 2 definitions. Dot product is equals to modulus A and then modulus of the vector B and then cos theta. Theta is the angle in between. Which if I have to signify it with a triangle here, there's a small triangle just to understand that better. Theta is the angle in between. In this case, the angle OMC prime. So this is like the center here. So these 2 vectors that around the included angles, you must call this an included angle. Included angle means like the 2 sides are known. We use that in geometry, so we can kind of use it like that. And then we can also see that vector A, now using 3 dimensions, it becomes something like this. So it's an I, sorry, like in the A1 is the component in the I direction, B1 is the component in the J direction, and C1 is the component in the K direction. So the vector B, it's a general definition. Please take note. Aha. So we can just use, actually you can call it however you like, but I think it would have been best to call it in the same letter A. That's why some people don't write the ABC like that. What they do is they use the letter A itself. That means A1, A2, J. I think this is more standard in the books. It's been a while since I looked at those texts. Okay, but just taking some from memory, some parts, yeah. So B1, I like that. So B2 is the component along the second dimension. This is B2, J, third dimension, B3, just the K. Okay, what is this thing? So this dot product can be proven to be linked to 2 things. Not only it can be computed like that, we can show with coordinate geometry. That's geometry, is coordinate geometry. That in value, when you know the coordinates of A, A1, A2, A3, this are actually coordinate values, the IJK direction. This can also be proven. The proof we're not doing now, we're doing more exam preparation. So A1, B1, multiply then plus A2, B2, and plus with A3, B3. Aha. Let's take note, this one. So this is the link. You must understand where the idea comes from, what they're trying to do. Based on this, we have this coordinate system. That means if I were to mark it on the picture, a little bit to make it a bit more clear. So, but we can't really, not to say can't really mark it. We can. It's just like a coordinate system. So I'm just going to show the 2 coordinates now. So MO and MC prime. So remember that we're going along the 2 vector. So it doesn't really matter the coordinate because this is not really a coordinate because the M is not the origin. So I can't really point to that. But you'll understand what I'm talking. All right. See, the idea is what? The idea is to link these two. These two are the same. Okay. These two calculations in a dot product, three-dimensional dot product. There's also a two-dimension version of the same thing. So there used to be A1, B1, A2, B2. So in 3D, that's what they do in A-levels. You just need to put these two same, that's all. So sometimes they teach you a formula, but now you see it why it's a component, it's the same thing. I'm just mentioning the formula, please take note. So we need to calculate like this. So modulus of A, and then multiplied by the modulus of B, and the cos theta, theta will be the angle in between, just a link to geometry, is equal to the A1, B1 plus A2, B2 plus A3, B3. Now, the A1, A2, B2, and A3, B3 is the link to coordinate geometry. So you must understand what's happening between the two things. So that's how the definitions correlate. Now, so that means, now let's look at the two vectors we have here. So on the left, we can see some of the vectors here. So what I'm going to do is I'm going to erase the center because the diagram is not necessary at this point. I'm going to force the link from left to right. So let's kind of like move this up. And then we're going to put a separation bar on these two so that we can see the two things, how they're linked and all that. Okay. So what am I saying? Okay, let's have a closer look now. This is in details. So this is like our vector A. So I'm just going to label it as A now. Let's call this as A and this as B. Remember, please, that we're talking about the angle in between the two. That means if you recap from the earlier picture, this is, what is the word? OMC prime. Okay, so this is like C prime at the top there. This is O here, OMC prime like that. Okay, that means you'll understand MO and MC prime. The top right corner here, this label there, you can see easily. So the MC prime is the A actually under that definition. So I just need to change just a little bit. Sorry, this is not A. This is actually B. And this is A. Can you see why? In the picture on the right, this is actually MO is the B in our case. This is the A. I just do maybe a smaller picture here just to repeat that in case that becomes a stumbling block. So let's think of it like this. So this is a M here. This is a O. This is the point C prime. Please compare with the original diagram. This is like here. MO is down here. With the arrow, you can see this is A. Sorry, it's a B. This is the B. Sorry, this is what I was trying to correct this now. Because normally we used to write A first. That's why it came first. Sorry. So B and then the MC prime is the A upward. So, and the angle in between of them from where they break out like an included angle definition in geometry, analogously. So that would be the angle theta. The symbol is called theta as a symbol in Greek. Okay, so we have these two things here. So that means now I just need to do some computations. So let's compute that, please. So I'm going to do some computation here, down here. So let's say we take the A, we start down here, is 4I plus 4J and the 6K here. That means if you compare with the original definition, the A1 thing, you'll notice the A1, A2 thing and all that. So the A1, A2 thing is what? This is A1, this is A2, this is A3 from here. So I'm just going to put an arrow to show that. Oh, so what I need to calculate from here. So what we need to calculate is the modulus of A itself. So the modulus of A is standard definition. When you got the IJK components, you just take like A1 square, the component square, and B1 square plus C1. Sorry, I keep doing the A1, B1, C1. Sorry. Here we define it as A2 square and A3, the coefficients of the IJK. The units being 1, so then just reduce to this. So the numbers are therefore 4 square, square root under the square root plus, so 4 square plus 4 square plus 6 square. Okay, let's calculate that please. So 4 square and 6 square means 4 square and 6 square adds up to 68. So just leave it like that, it's okay. Even if you didn't reduce it or reduce the third, I mean, root of 68. So similarly, let's calculate please the square root or the modulus likewise for vector B. So vector B, So to copy it first down here, up here, sorry, is 4i. Please take note. I'm just going to add the j part, even though it doesn't have a j there, just to signify this. The component is 0. So j part is 0, huh? And then, oops, sorry, yeah, horrible handwriting. All right, so j like that minus 6k, and then we do a modulus of the b itself. Okay, so the modulus of a b will be square root of this is 4 square plus 0 square plus minus 6 whole thing square. Okay, modulus is a scalar. It doesn't have a vector, so please don't write any I or j to it. So let's add it up, please. So 16 plus 36. Aha. So it turns out to be square root of 52. So this is square root of 52. Huh? Please take that. Oh, so the modulus of b is square root of 52. Okay, now we need to combine all of this in a while, but let's say I just call it now, label it. Huh? This, let's say, equation 1 or result 1. This is result 2. And then we want to calculate in another way, right? So we want to do one more thing. So the other thing that we want to calculate is from this line. Ta-da-dan. Okay. So the modulus, the dot product of A dot B, dot like that, huh, equals to A1 B1 plus A2 B2. Sorry, I still keep doing the A1 correctly. A2 B2 and A3 B3. This is labels, huh? Okay, so now we use the coordinate geometry way of calculating the same thing in two different ways. That's how we're going to relate it. So it slowly makes sense. So please recall that this is the B1, B2, and B3, which I didn't label. The A1, A2, A3 are labeled down there. So A1 is 4 down here, for example. A1 is 4, B1 is also 4 up here. So 4 bracket 4, this right brackets please. Second one, A2 is 4, B2 up there is 0. Aha. So 4 with a 0 plus the A3 down here is 6. And then the B3 up there is negative 6. So we just want to calculate like that, negative 6. Huh? So it becomes 16 minus 36 or negative 20. Okay, please take note, it's negative 20. Oh, that means all this tells me that the dot product turns out to be a scalar, which is negative 20. Scalar means no vector value. Huh? Okay, so just a magnitude. So here we are. So we pull this off. So all we need to do is, let's call this equation of the identity 4. So we put 1, 2, 3 in 4. That's it now. So putting the results 1, 2, 3 in 4, what happens? Oh, the modulus A, remember in 4, I'm pulling off this line. So it's a coincidence, exactly the same line. So modulus of A is this value. Try to use the same color so you can recall. So root of 68, let's say I put in the bracket. And then the modulus of B, as you can see at the top there, will be root of 52 as I read it from equation 4 here. And then cos theta in red, just copy only, cos theta equals to, this entire thing, A1, B1, this thing, so result 3. So in the result 3, you can see that easily this is negative 20. Oh, this negative 20 lah. Okay, so that means now I can just rewrite this. So cos theta will be equals to, let's see, negative 20 over this third thingy lah. So this third things, yes, we just compute it. So root of 68 multiplied by root of 52. So we calculate this nicely. And we can put in the calculator, please. Theta will be arc cos of that. So straight away, just put in the calculator. Okay, whichever way is easier for you. All right, root of 68 times root of 52. Huh? So shift cos. So I'm computing it using. You can easily see that it's an obtuse angle. So you put a negative, the calculator can tell you the first obtuse angle. Cos is negative means obtuse. Just put a note there. Please take note. Cos theta is negative or less than 0 means theta is obtuse in the second quadrant being a triangle. It cannot be in the third quadrant also, because that's beyond a triangle value, which is between 0 to 180 degrees. So this becomes 109, what do we say, 0.65 degrees. The degrees of accuracy, you have to see the, what do we say, requirement in the paper, which I'm not too well with. So that's how you find the angle between the two, by using the dot product. Thank you.